composition of functions. You guys deal with this more often than not, and you don't even realize it. Composition of functions is simply just putting two functions together in a certain way. Say, for example, that you go out and you're going to go buy brunch. Okay. So you order whatever you are going to have for your meal. Is that all that it's going to cost you? No. You have to take into account tax, and you should take into account a tip, correct? And those two things are based on the total cost of what it is that you do. Do you want to go and calculate the total cost on the meal with tax and then calculate what the tip is based on the meal and tax? No. So you calculate it on the meal itself for the tip, calculate the tax on the meal itself, not the tip, and then you combine all these things together. You're putting together a bunch of functions. So, given two functions, the composition is always going to be read as F, and let's get this open circle and a G. That's read as F composed as G. Now, I do not like the composition notation. It's a little annoying at times and difficult for students to get figured out what the proper order is. So, I highly recommend that whenever you are going through and doing this, you write your compositions in this function format. Because F composed with G means that we do the G function first, get whatever that is, then put that into the F function. That's how this goes. So, we'll talk about domains as we get through these things. So, I want to evaluate the composite of a function. So, grab this. Take a look at this. So what we want to go through here, we identify f of x as 2x squared minus 3 and g of x as 4x. Now, I like going through and setting this up with the function notation. And as I am going through and doing this, you'll kind of see why I like it that way. Okay. When I write this out like this, we're working from the inside out, just like it says parentheses. So I'm going to write this as f of x, or f of what is x supposed to be in this case? F of g. F of g. Now what's the g function? That's 4x, but what am I going to put in for x? 1. So, that means that I've got f of 4. Does that make sense? Because whatever, I got 1 here, punch it in there, see what I get. So now I am going to put f of 4 into here, which is going to be 2 times 4 squared minus 3. So we end up with 16 times 2, 32. So that would end up being 29. Okay. I like doing it this way. It just seems to be more intuitive. You put the 1 in for the function, calculate it, get the answer. Now that you've got it set up with that, you can plug it back in and go. But I always want to make sure that I write down what this is. So this is going to be g of f of x, or in this case where x is 1, so I want g of f of 1. So what's that going to look like? Well, that's going to be g of, what is the f of x function? Well, that is going to be 2 times 1 squared minus 3. Let's see, 1 squared is 1 times 2 is 2. 2 minus 3 gives me negative 1, correct? Did I do that right? Yep. So I got g of negative 1. So now that goes into the g function, so that gives me 4 times negative 1, and I end up with 4. That's all it is. It's just a way of identifying how to put the different functions together. So let's take a look at the other two. I've got f composed with f. Well, that's no big deal. f of, what are we working with? Negative 2. So that means that I got f of, so that 2 times negative 2 squared minus 3. Let's see, that's going to be 4. 4 times 2 is 8. 8 minus 3 is 5. So we got f of 5. So now just put into there. So we get 2 times 5 squared minus 3. So 5 squared is 25. Times 2 is 50. So we end up with 47. Not too tough, is it? It's just understanding the notation and seeing how it works. So if I do the last one here, that's g of negative 1. So that gives me g of, well, that's going to be 4 times negative 1, which gives me g of negative 4. So that's going to give me 4 times negative 4, which gives me negative 16. Again, all you're doing is plugging it into the function from there. But again, this is rather complicated at times, so please make sure that you're writing it out and showing everything. That way you can see your progression as you're looking at these. So, let's about... So now, let's talk about dealing with its domain. So, just a little bit. So, if I'm looking at what we have here, they give us x squared plus 3x minus 1, they give me that. Is there anything that I can't put into the f function? The answer would be no. We don't have to worry about a denominator, nor do we have to worry about even root. Likewise with g's. So both of those are going to be allowing any real number. So that's why they say the domains of a set of real numbers. Let's take a look at this one now. So, find the domain of this one. Now, if we look at this, does f of x have a limit to its domain? Is there something that it cannot be? And that's negative 2, correct? What about g? Is something there that it can't be? Well, that would end up being 1. So I cannot use negative 2, correct? But now, can I put negative 2 into the g function? Does that work? So, when they did this, they picked negative 2, put it into the g function, got negative 1, right? So we are also going to exclude negative 1 from the domain as well. So, the domain of f of g of x is as follows. X cannot be equal to negative 1, and x cannot be equal to 1. Well, why 1? Well, if I put 1 in here, that gives me undefined, correct? If I put in negative 1 for x, for this one, when I plug it in, negative 1 actually goes through and turns itself into negative 2 after I work this out. See that? So, I can't go and use that one. Now, how they figured that out is put negative 2 in, did the math, got negative 1 out. So if the value of negative 2 comes in, I get that. So if I put in negative 1, be careful about that, because that generates the number of negative 2, and negative 2 doesn't work. Yeah. So let's try that again. So I've got these. What cannot be used for the first here? X cannot be equal to negative 2, correct? Here, x cannot be equal to 1. So, if I want to go and take f g of x, that is going to be f of g of x is simply 4 over x minus 1, correct? Now this is where things start getting a little bit trickier. We haven't been told what x is, have we? So now this is going to go in for x up there. So that means I am going to have 1 over, parentheses, 4 over x minus 1 plus 2. This is where it starts getting smart. Because now we have to use the rules of fractions in order to deal with this. I have a denominator of x minus 1, so I am going to multiply this one here by x minus 1 over x minus 1. Does that make sense to do? Common denominators. So I'm going to do a little side math over here to work this out. So this is going to end up being 4 over x minus 1 plus 2 times x minus 1 over x minus 1. Yes? Now you're going to get 4 plus distributive property 2x minus 2 all over x minus 1. Yes? Add like terms, we end up with 2 over 2x plus 2 over x minus 1. Okay. Can I do any more simplifying with that? The answer is no. So, still not done yet. This happens to be 1 over 2x plus 2 over x minus 1. Can I multiply or divide by a fraction? I can't divide by a fraction, but I can multiply by its what? So this goes up here as x minus 1 over 2x plus 2. So, once I do all this simplification, I end up with the following. This is going to simply be x minus 1 over 2x plus 2. Okay. So I've got the composition of the function. What about its domain? Let's take a look at how they worked things out and see if they ended up in the same place I did. They got it all worked out. So the domain can't be negative 2 and the domain of g cannot be 1. So when we took a look at this, we found out what happens when we plug these things in. So, if I can't have 2 for this, what value goes in here to create that 2? State it that way. If I put in negative 1 here, correct? That gives me 4 over negative 2. Divide 4 by negative 2, I get negative 2, correct? And if I take that negative 2, I put that in over here. That Can't be done. So, when you're doing this, the order is going to matter. I know that I can't put 1 in here, right? I know I can't put in -2 here. So one of the ways that you could really do this is you want to solve for 4 over x minus 1 is equal to -2. What makes that equal to -2? Does that make sense? So we'd end up doing the math. We end up with 4 over -2 is going to be equal to x minus 1. Let's shift here, right? So -2 is equal to x minus 1. Add 1, and I end up with -1 is equal to x. So that's why we cannot have x is equal to 1, and we cannot have x equal -1. Go. Kind of confusing? Yes. If I were to go through here and do B, I'm only worried about this. X cannot be equal to -2, correct? But what happens if what number do I put in here to make it -2? So we're going to work that out. 1 over x plus 2 is equal to -2. So that means that I've got 1 over -2 is equal to x plus 2. Let's see, subtract 2. So that means that I would have to have that -2.5 cannot be equal to x. Correct? So, if I plug -2.5 into this, I get out the answer of -2. And when I take that -2 and put it into the other function, that makes it go back. Okay, put it that way. So, when we're talking about this, the domain here ends up being -5 over 2, which is our -2.5, right? And -2. Those are the two things we cannot put together. Questions? Sometimes we're going to run into this situation showing that two composite functions are equal. If I go through and do f composed with x, it's the same as taking g composed with x and I get x. Huh? Think of it this way, these are functions that undo each other. They're inverses of each other. And this will happen. Don't think I want to go through that. Let's see. This one here can be a little bit on the trickier side. Finding the functions that are composed to go through and make this. When we get to those, we're just going to simply take some time and work through them. I'll kind of talk about what it is that they've got now. Because it talks about this one, function h takes x squared plus 1 and raises it to the power of 50. Now, a natural way to decompose this thing would be to say that, oh, the g function is x plus, or x squared plus 1. The f function could be x to 50. That makes sense. You almost got to think about it in order of operations. What can I do first? What can I do second? What can I do third? So I could do the x squared plus 1, get an answer, then plug that in to something to 50 power. Are there other ways that this could have been decomposed? Oh, sure. So, I'll let you guys get to work on this so that we can get to the good questions.